Hello, this is the lecture number 3 for the chapter inverse trigonometric function for the class 12th. And we are in last lecture we discussed the exercise 2.1. Now we are discussing the exercise 2.2. Now in this question number 1, you have to prove that 3 sine inverse x is equal to sine inverse 3x minus 4x cube. So to prove them equal, let us say that we are letting sine inverse x is equal to theta. So the value of x will be equal to sine theta. Now, as we have let sine inverse x is equal to theta, so the left hand side will become 3 theta. Now, to prove them equal, we should prove that this is also equal to 3 theta. So, right hand side, replace the value of x and x here, which is equal to sine theta. So, 3 sine theta minus 4 sine cube theta. And this is the formula for sine 3 theta. So, sine inverse sine theta is equal to 3 theta. So, they are equal to each other. Therefore, we can say that this 3 sine inverse x is equal to sine inverse 3x minus 4x cube. Similarly is the question number 2, in which you have to prove that 3 cos inverse x is equal to the right hand side. Question number 3, simply you have to prove that you have to use the formula tan inverse x plus tan inverse y in this. So what is the formula? Tan inverse x plus y upon 1 minus x into y. Simplify, you will get the right hand side. Question number 4, it is 2 tan inverse half plus tan inverse 1 upon 7, and you have to prove that it is equal to tan inverse 31 upon 17. So we know the formula of tan inverse x plus tan inverse y, but we have 2 before this tan inverse x. So use the formula of 2 tan inverse half, use the formula 2 tan inverse x, which is equal to tan inverse 2x upon 1 minus x square. 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. Simplify it, we are getting 4 upon 3. Use the formula of tan inverse x plus tan inverse y, that is tan inverse x plus y upon 1 minus x into y, which will give tan inverse 31 upon 70, which is equal to the right hand side. Now question number 5 onwards are important because you have to simplify it and the given trigonometric expressions. Now you have to simplify it. Tan inverse under root 1 plus x square minus 1 upon x. Now if we let x is equal to tan theta, this square would be simplified. So put x is equal to tan theta, it will be 1 plus tan square minus 1 upon tan theta. Convert into sine and cos. 1 plus tan square is sec square square root is sec theta. Convert into sine and cos, which is 1 upon cos minus 1 upon sine upon cos, which will give 1 minus cos theta upon sine theta. Now use the identity for 1 minus cos theta, which is equal to 2 sine square theta by 2. Sine theta identity is 2 sine theta by 2 cos theta by 2. Simplify, you are getting theta by 2. So tan inverse tan theta by 2 will be equal to theta by 2. And because the question is in terms of x, so you have to convert this theta in terms of x. So theta will be tan inverse x. This is the simplified form of this expression. Now in question number 6, you have to simplify this tan inverse 1 upon under root x square minus 1. Now because we have tan inverse, so we should have 1 upon cot. To get cot here, we let x is equal to cosec theta. This trick you should know. So put x is equal to cosec theta. So x will be equal to theta will be equal to cosec inverse x. Now put x equal to cosec theta. So cosec square theta minus 1 will be there, which is equal to cot theta. 1 upon cot theta will be 10. But tan inverse tan theta is theta. Theta will be equal to cosec inverse x from here. So this is the simplified form of these types of questions. Similarly, in question number 7, we don't have to put anything here because we know the identity for 1 minus cos x, which is equal to sine square x by 2, and the 1 plus cos x is 2 cos x square x by 2. If you simplify it, you are getting this as tan x by 2. So tan inverse tan x by 2 will be equal to x by 2. You should know the identity for this. Learn it if you don't know. 1 minus cos is equal to 2 sine square x by 2. 1 plus cos x is equal to 2 sine square x by 2. 2 cos square x by 2 with the trigonometric identity. Now you have to prove that simplify this tan inverse cos x minus sin x upon cos x plus sin x. Now because we have here tan inverse, so you should have this expression in terms of tan. You have to use a trick, divide numerator and denominator by cos x. So this comes out to be 1 minus tan x upon 1 plus tan x. And you know the formula for this, it is tan pi by 4 minus x. This is the identity for tan pi by 4 minus x. So tan inverse 10 is equal to this portion. Tan inverse 10x is equal to x. Question number 9. If you let x is equal to a sine theta in the numerator as well as in the denominator, in the question number 9, you are getting a sine theta upon under root a square minus a square sine square theta. Replace the value of x by a sine theta. So if you take a square common from the square root, it will be a, it will be cancel out this a. So it comes out to be sine theta upon under root 1 minus sine square theta, which will be equal to cos theta. So sine theta upon cos theta is tan theta. So tan inverse tan theta is equal to theta. Now you find the value of theta from here. Now sine theta will be equal to x upon a, and theta will be sine inverse x upon a. Put it here. The value of sine theta will be sine inverse x upon a. So this is a simplified form of this given expression. Similarly is the question number 10. If you put x is equal to a tan theta here, a tan theta, if you put it here, so it comes out to be 3a cube tan theta minus a cube tan cube theta, a cube minus 3a square tan square theta. You take a cube common from the numerator as well as a cube from the denominator. You will get this. It will cancel out. Putting the value of x is equal to a tan theta, a cube tan square theta you will get. Cancel out this a cube. This is the formula for tan 3 theta. You should know it. If you don't know, learn it. Tan inverse tan 3 theta 3 theta, and the value of theta you will get from here. Tan theta will be equal to x upon a, and theta will be tan inverse x upon a. See it carefully. Question number 11. It is a simple question. Sine inverse half is equal to 30, that is pi by 6. So 2 into 30 will be equal to 60. Cos 60 is equal to half, and 2 into half is 1, and tan inverse 1 is equal to pi by 4. It is equal to pi. Tan inverse 1 is equal to pi by 4. You know it. This is all again a very easy question. Tan inverse x plus cot inverse x, you know it, pi by 2. That is tan inverse x plus cot inverse x is equal to pi by 2. So cot 90 is equal to 0. Question number 13. 10 half sine inverse 2x upon 1 plus x square plus cos inverse 1 minus y square upon 1 plus y square. Now you know this formula that 2 tan inverse x is equal to sine inverse 2x upon 1 plus x square, and 2 tan inverse y is equal to cos inverse 1 minus y square upon 1 plus y square. This formulas we have done in the last lecture, and we have also proved them. So you can take 2 common. Yes, so cancel out will be there. So tan inverse x plus tan inverse formula is tan inverse x plus y upon 1 minus x into y. This tan into tan inverse cancelled out. So you are getting x plus y upon 1 minus x into y. So this is the some questions of exercise 3rd of inverse trigonometric function. Let us take some more. Question number 14. If you see it very carefully, it is a tricky question. If you take this sign, you have to simplify it, or rather you have to solve it. Solve means you have to find the value of x. Now if you take this sign to the right hand side, it will become sine inverse 1, and sine inverse 1, you know it is at 90, and you are getting sine inverse x plus cos inverse x is equal to pi by 2. These two values should be same, then we have it equal to pi by 2. So the value of x will be equal to 1 upon 5, because sine inverse x plus cos inverse x is equal to pi by 2. You must know this identity or the formula. So these should be same. So the value of x is equal to 1 upon 5. Now this is the important question number 15. You have to solve it. Solve it means you have to find the value of x. So simplify the left hand side. Tan inverse x plus tan inverse y formula is tan inverse x plus y upon 1 minus x into y. Tan inverse x plus y formula is tan inverse x plus y upon 1 minus x into y. Now if you take tan inverse to the right hand side, it will become tan 45. It will become tan 45. Tan 45 is 1. Simplify this expression. You will get a quadratic equation, and solve this quadratic equation, which will give x is equal to plus minus 1 upon root 3. Simplify this bracket. Maximum term will be cancelled out. Open this bracket. You will get a quadratic equation and solve to get the value of x. Now in question number 16, you have to find sine inverse sine 2 pi by 3. Now we know that formula is sine inverse sine x is equal to x, and x should be in its principal principal value, principal domain में होना चाहिए. But this 2 pi by 3 is not lying in its principal value. Principal value के बीच में नहीं, because the principal value of sine inverse is from minus 90 to 90. So this 2 pi by 3 is 120, which is not lying in its principal solution. So we break it 120 as 180 minus 60. So sine 180 minus theta is sine theta. So sine inverse sine x is pi by 3, which belongs to its principal solution, that is from minus 90 to 90. So these three types of questions are there. That is question number 17 and 19 also. Again, we have tan inverse tan 3 pi by 4, and 3 pi by 4 is not lying in the principal solution of tan inverse, which is between minus 90 and 90. So break this 135 angle is equal to 180 minus 45. Tan 180 minus theta is minus tan theta, because it lies in the second quadrant, and we know that tan inverse minus x is equal to minus tan inverse x. Tan inverse minus x is equal to minus tan inverse x, and tan inverse tan pi by 4 is equal to pi by 4, which lie in its principal solution. Why we have break that? Because 3 pi by 4 not lying in principal value branch of tan inverse trigonometric function. Similarly, we have cos inverse cos 7 pi by 6. This 7 pi by 6 angle is 210, which is not lie in the principal solution of cos, which is 0 to 180. Therefore, we are breaking it. It is 210. So 180 plus 30, it is 210. It lie in the third quadrant. In third quadrant, cos is negative, and we know that cos inverse minus x is equal to 180 minus cos inverse x. We know that cos inverse minus x is equal to 180 minus cos inverse x. In here, x is cos pi by 6. So cos inverse cos pi by 6 is equal to pi by 6, and simplify, which will give 5 pi by 6. Now, why we don't have written cos inverse cos 7 pi by 6 is equal to 7 pi by 6? Because this 7 pi by 6 does not belong to principal value branch of the cos inverse. That is why I break this angle to convert into the principal value branch of the cos inverse, which is 0 to 180 degree. Now, I'll discuss the remaining question in the next lecture. Thank you.